Hello, good morning. Good morning to all. In the last class, we have seen Newton's divided difference interpolation formula, how to find the polynomial and how to find the values of the given function at any given point inside the data points and outside the data point. Now, today we will discuss about data approximation and Neville's method. So what is Neville's method? In mathematics, Neville's algorithm is used for polynomial interpolation. So it is used for polynomial interpolation. Interpolating the polynomial, we use Neville's algorithm that was derived by the mathematician Eric Harold Neville. So this is the name of the mathematician Eric Harold Neville, who derived this algorithm. So this algorithm is called Neville's algorithm. So for a given n plus 1 points x0, x1, x2, x3, xn, there is a unique polynomial of degree less than or equal to n which goes through the given points. The main idea of Neville's algorithm is to approximate the value of a polynomial at a particular point. So there are steps involved in interpolating the polynomial using Neville's method. So they are as follows. So let us see. I'm sharing the screen. So how to determine, how to derive the formula and what is the use of this Neville's method. So in Neville's method, we approximate the values. So Neville's method. Now see this. I am sharing the screen. Data approximation and Neville's method. So see here, what is data approximation? In mathematics, Neville's algorithm is used for polynomial interpolation that was derived by the mathematician Eric Harold Neville for a given n plus 1 points, that is x0, x1, x2, xn. There is a unique polynomial of degree less than or equal to n which goes through the given points. The main idea of Neville's algorithm is to approximate the value of a polynomial at a particular point. So the steps involved in interpolating the polynomial using Neville's method are as follows. So the first step is assign the values. F of x0 is equal to q0, 0. F of x1 is equal to q1, comma 0. F of x2 is equal to q2, comma 0, and so on. F of xn is equal to qn, comma 0. So this is nothing but f of x0 is equal to y0, f of x1 is equal to y1, f of x2 is equal to y2, and f of xn is equal to yn. So instead of saying y0, we are saying here q0, comma 0. F of x1 is q1, comma 0, and so on. So this is the first step. You have to assign the values of the given function f of x0, f of x1, f of x2 for the given values of x. We have to assign the function f of x0 as q00, f of x1 as q10, f of x2 as q20, etc. f of xn is equal to qn, comma 0. So this is the first step. For the given data points, we have to assign the values. The next step is step 2. The approximations can be calculated by using the formula. So this is the formula. qi comma j is equal to x minus xi minus j into qi comma j minus 1 minus x minus xi into qi minus 1 comma j minus 1 by xi minus xi minus j. So this is the formula to calculate the further approximations. So what values I will take? I takes values 1, 2, 3 dash dash n and j takes values 1, 2, 3 dash dash I. For example, if we take I is equal to 1, j is equal to 1, then we get this coefficient qi comma j is equal to x minus x1 minus 1 0 x minus x naught into q1 comma 1 minus 1 is 0 q1 comma 0, this is minus x minus xi, I is 1, so it becomes x minus x1 into I minus 1 j minus 1 1 minus 1 1 minus 1, it becomes q0 comma 0 by xi minus j. Xi is x1 minus I minus j, 1 minus 1 is 0. So q11 will become x minus x naught into q10 minus x minus x1 into q00. Similarly, if we take I is equal to 2, j is equal to 1, we get q2 comma 1 is equal to x minus x1 into q2 comma 0 minus x minus x2 q1 comma 0 by x2 minus x1. So we have to substitute here I is equal to 2, j is equal to 1. So it becomes x minus x2 minus 1, 1. So it becomes x minus x1 into I is equal to 2, j is equal to 1. It becomes 2 comma 0. I is equal to 2, x minus x2. I is equal to 2, 2 minus 1, 1. J is equal to 1, 1 minus 1, 0. So it becomes q2 comma q1 comma 0. So this is q2 comma 1. Similarly, if we substitute I is equal to 3, j is equal to 1, we get q3 comma 1. So q3 comma 1 will be x minus x2 into q3 comma 0 minus x minus x3 into q2 comma 0 by x3 minus x2. Similarly, if I is equal to 3, j is equal to 2, we get q3 comma 2 is equal to x minus x1 into q3 comma 1 minus x minus x3 into q2 comma 1 by x3 minus x2 and so on. So this is the second step in which we have to use the formula for finding approximations. So the formula is qi comma j is equal to x minus xi minus j into qi comma j minus 1 minus xi minus x minus xi into qi minus 1 into j comma j minus 1 by xi minus xi minus j. So this is the second step. So in third step, we have to construct the table that is called recursive table. So how to determine this recursive table? The first value, first column is xi. So these are the values of the x values. First column is for x values, x naught, x1, x2, x3 dash dash xn. So n plus 1 points are given. Corresponding value of the function is, this is y0. Instead of y0, we are writing here q0 comma 0. Instead of y1, we are writing q1 comma 0, q2 comma 0 dash dash qn comma 0. So this is the first approximation. So in first approximation, the value is q11, q21, q31 dash dash qn1. So these values we have to calculate it. We have to calculate or we have to approximate the polynomial. This is first. This is called first approximation. Similarly, in this column qi comma 2, we have to determine q22. This is second degree approximation. q32, q42 dash dash qn comma 2. Similarly, if we go on finding the approximations, the last column is qi comma n. So we will get here qn comma n. So these are the calculations, and this table is called recursive table. So these are the values of x in the first column. In the second column, the values of the function at x is equal to x naught, at x is equal to x1, at x is equal to x2, and dash dash at x is equal to xn. These data points will be given. We have to determine the first approximations, second approximations, third approximations, and so on. So for the given data points of x and y, q11x. If we substitute I is equal to 1, j is equal to 1, we get q11x. So q11x is equal to x minus x naught into q1 comma 0 minus x minus x1 into q0 comma 0 by x1 minus x naught. So this is called first degree approximation. Similarly, to find second degree approximation, we have to substitute I is equal to 2, j is equal to 2 to get q2 comma 2 x. So by substituting I is equal to 2, j is equal to 2, we get this polynomial x minus x naught into q2 comma 1 minus x minus x2 into q1 comma 1 by x2 minus x naught. So this is called the second degree approximation. Similarly, we can determine the third degree approximation as q3 comma 3 of x is equal to x minus x naught into q3 comma 2 minus x minus x3 q2 comma 2 by x3 minus x naught. So these values are obtained by substituting in the formula Qij is equal to. In the second step, we have written this formula. In this formula, if we substitute I is equal to 1, j is equal to 1, we get this polynomial Q11, Q11x. So this is called first degree approximation. If we substitute in this formula I is equal to 2, j is equal to 2, we get q2 comma 2, and if you substitute I is equal to 3, j is equal to 3, we get q3 comma 3, which is called the approximation of third degree. So q11, q22 and q33, these are the first degree approximation, second degree approximation and third degree approximation. So we can determine 4, q44x, q55x, etc. Now, one problem we will do on Neville's method. So the problem is use Neville's method to obtain the approximations for Lagrange's interpolating polynomials of degree 1, 2 and 3 to approximate f of 8.4 if f of 8.1 is given as 16.94410, f of 8.3 is 17.56492, f of 8.6 is 18.50515 and f of 8.7 is 18.82091. So what we have to determine? So in the given problem, it is given that what is given? X values are given. So what are the X values? 8.1, 8.3, 8.6 and 8.7. So 8.1, 8.3, 8.6, 8.7. So this is the column for Xi, and the first value is X0, second is X1, third one is X2 and fourth one is X3. So the corresponding value of the function is Qi comma 0. So this is Q0 comma 0. This is nothing but Y0. So at x is equal to 8.1, the functional value is 16.94410. Similarly, at 8.3, the functional value is 17.56492. Similarly, we are writing here at 8.6, the value is 18.50515. At 8.7, it's 18.82091. So this is the first value of y0, which is nothing but q00. This is q10, q20, q00. This is zero approximation. This step is first approximation. This step is second approximation, and this is third approximation. Now, in the question, it is given that obtain the approximations for Lagrange's interpolating polynomial of degree 1, 2, and 3 to approximate f of 8.4. Now we have to determine the value of the function at x is equal to 8.4. So 8.4 lies between 8.3 and 8.6. So our value should be in between 17.56492 and 18.50515. If we obtain the value in between these two, then it is obvious that we are going right. So this is the problem. So we have to determine first degree approximation, that is Q11, second degree approximation Q22, and third degree approximation Q33 at the point 8.4. So see here what is given. We are writing here x0 is 8.1. What is x1? 8.3. x2 is 8.6. x3 is 8.7. Now what is x? Which value we have to determine? At x is equal to 8.4. What is the value of the function? So at x is equal to 8.4, we have to determine the value of the function. So what is 8.1? This is f of x naught. It is q00. It is given 16.94410. F of x1, it is f of 8.3. Its value is given here. It is q1 comma 0. This is q2 comma 0, and this is q3 comma 0. So we have written all the values given in the table. Now what we have to determine? We have to determine interpolating polynomial of degree 1, that is q11x, second degree polynomial, that is q22x, and third degree polynomial, that is q33x, and values of the polynomial at the point x is equal to 8.4. So this is our problem. Now the first degree polynomial, first degree approximation is given as q11x. So you have already defined what is q11x. If you substitute x I is equal to 1, j is equal to 1 in the formula, we will get q11x, and q11x is called the first degree approximation. So by substituting I is equal to 1, j is equal to 1, we get this q11x is equal to x minus x naught into q10 minus x minus x1 into q00 by x1 minus x naught. So we know the value of x naught and x1 and q10, q00. These values we know from the given data. Substitute here the values of x naught, x1 and q00 and q10. So on substitution of the given values, we get q11x is equal to. So what is q11x? q11x is equal to x minus x naught. What is x naught? X naught is 8.1. So in the table we have seen x naught is 8.1, and this is q of 1 comma 0. So let us see what is q00. X naught is 8.1, x1 is 8.3, x2 is 8.6, x3 is 8.7, and these are the values of q00, q10, q20, q30. So these values we are substituting in the first degree approximation. So see here, we are substituting the values. X minus x naught is 8.1, q10 value is 17.56492, minus x minus x1 8.3 into q00, this is the value of q00, by x1 8.3 minus 8.1. Now multiplying this with x 17.54692 into x minus 8.1 into this is 142.2758520. So by using calculator we can determine the value. We can find the product. Minus x into 16.94410 is 16.94410x, minus into minus plus 8.3 into 16.94410 is 140.63603, by 8.3 minus 8.1 is 0.2. Now simplifying the values, so collecting x values 17.56492 minus 16.94410x is 0.62082x. So these are the constants. So after simplification we get the value as minus 1.639822 by 0.2. So this is the first degree approximation. Now we have to determine the value at x is equal to 8.4. Now substitute here x is equal to 8.4. We get q11 8.4 is equal to. So this as it is. In place of x we are substituting 8.4 minus 1.639822 as it is by 0.2. Now after simplification, after calculation, we get this value as 17.87533. So this is first degree approximation. Now the other first degree approximations are q2 comma 1, q3 comma 1. So how to find q2 comma 1? By substituting I is equal to 2, j is equal to 1 in the formula, we can get this. So q21x is equal to x minus x1 q2 comma 0 minus x minus x2 into q1 comma 0 by x2 minus x1. So this is only by substituting the values of I is equal to 2, j is equal to 1, we get this first degree polynomial, other polynomial, first degree polynomial, q21 x is equal to. Now again, you have to substitute x1, x2 values, q2 comma 0, q1 comma 0 values we know from the given data. Substituting here the values, it becomes x minus 8.3 into 18.50515. This is the value of q2 comma 0 minus x minus x2. It is 8.6 into 1 q1 comma 0 value is this. Now again we are recollecting the x terms and constant terms. So after writing, simplifying, we can write this q2 comma 1 x as 0.94023x minus 2.534433 by 8.6 minus 8.3. In the denominator we get 0.3. So this is q2 comma 1. So at the point x is equal to 8.4, the value of 2 comma q2 comma 1 is, in place of x we are substituting 8.4. So after calculation we get this value as 17.87833. Similarly, the next first degree approximation is q3 comma 1 x. So by substituting I is equal to 3, j is equal to 1, we get x minus x2 into q3 comma 0 minus x minus x3 into q2 comma 0 by x3 minus x2. So again, substituting the values of x2, x3, q2 3 comma 0, q2 comma 0, we get this value, we get this function. After multiplication, simplification, we get the polynomial q3 comma 1 x as 0.31576x minus 0.865021 by 0.1. So this is the value of the denominator. Now again, we have to determine the value of the first degree approximation q31 at the point 8.4. So in place of x, if we substitute 8.4, we will get the value of q31 8.4, and it is 17.87363. So we got all the first degree approximations q1 comma 1, q2 comma 1, q3 comma 1. So this is the first degree approximations. In first degree approximations q1 1x, q2 1x, q3 1x, the best linear approximation is considered as q2 comma 1. So q2 comma 1 is the best linear approximation of first degree. So as 8.4 lies between 8.3 and 8.6, so q2 comma 1 is considered to be the first best linear first degree or linear approximation. Now we have to calculate. So what is the first degree linear approximation? That is q2 comma 1. So q2 comma 1, 8.4, that is 17.87833 is the first degree approximation. Now again we have to determine second degree and third degree approximations. Now we have to calculate second degree approximations. Now how to calculate second degree approximations? What are the second degree approximations? So q22, q32 are called the second degree approximations. So how to determine q22? If you substitute I is equal to 2, j is equal to 2, we will get q22. So in place of I and j, we are substituting 2, so we will get the value of the function q22 x is equal to x minus x naught q21 minus x minus x2 q11 by x2 minus x1. Again, we know the values of x naught, x2, q21 and q11 in the first approximation. So substituting the values, what we have get in the first approximations, first degree approximations. So x minus x naught value is 8.1, q21 is 17.87833, x minus x2 is 8.6, q11 value is this by 8.6 minus 8.1. Again, simplifying, collecting the terms, x terms and constant terms, we get this 0.003 into x minus 8.913365 by 0.5. So this is the second degree approximation. So again, second degree approximation Q22 at x is equal to 8.4 is obtained by substituting x is equal to 8.4. So by substituting x is equal to 8.4 and simplifying, we get the value as 17.87713. Again, the second degree approximation is Q3 comma 2x. So by substituting I is equal to 3, j is equal to 2 in the given formula, in step 2, we will get x minus x1 into q3 comma 1 minus x3 into q2 comma 1 by x3 minus x2. So substitute the values of x1, x3, q3 comma 1, q2 comma 1. So we will get here x minus 8.3. This is the value of x1. q3 comma 1 value is 17.87363 minus x minus x3, q2 comma 1. We are substituting the values. X3 minus x2 8.7 minus 8.3. So this is 0.4 in the denominator, and after calculation we get the polynomial as minus 0.0047x plus 7.190342. So this is the value of Q32x, that is second degree approximation. At x is equal to 8.4, what will be the second degree approximation, that is Q3 comma 2? 8.4 is equal to, in place of x we substitute 8.4 and simplifying we get 17.877155. So this is the second degree approximations. So Q22, Q32 are second degree approximations, and here Q32x is considered to be the best quadratic approximation. In first linear approximation, first degree approximation, q2 comma 1x is considered to be the best approximation. For second degree approximation or quadratic approximation, q32x is considered to be the best approximation, as 8.4 lies near 8.3. So this is second degree approximation. Now again, in the problem it is given that find the first degree, second degree and third degree approximations. So the third degree approximation is given by Q33x. So in place of I, if we substitute I is equal to 3, j is equal to 3, we will get this relation. This is the formula, x minus x naught into q3 comma 2 minus x minus x3 into q2 comma 2 by x3 minus x naught. Substitute the values of x naught, x3 and q3 comma 2, q2 comma 2. These are the second degree approximations. What we have determined, we have to substitute the values. This is q3 comma 2 values and q2 comma 2 values. q2 comma 2 is 17.87713 and q3 comma 2 is 17.877155. So we know the values of x naught and x3, q22 and q32. We are substituting the values here and simplifying, we get the polynomial q33x as, this is the third degree approximation, 0.000025x plus 10.7260755 by difference of this is 0.6. Now again we have to determine the value at x is equal to 8.4. So in place of x, if we substitute 8.4, we will get the value of Q33x, Q33 8.4, that is third degree approximation at x is equal to 8.4 is 17.877142. So after getting all the approximations, first degree, second degree and third degree approximations, we can tabulate the values or approximations as shown in the table. So in the first column, this is xi, these are the arguments, values of x. So 8.1, 8.3, 8.6, 8.7. So this is x0, x1, x2, x3. And qi comma 0, this is the second column. This is nothing but y0 or f of x0, which is denoted here by q0 comma 0. And this value is q1 comma 0, f of x1, f of x2, this is q2 comma 0, this is f of x3, q3 comma 0. So these are called zero approximations, 0 degree approximations. Now here qi comma 1, This is called first degree approximation. So this is Q11, this is Q21, Q31. So this is second degree approximations, Q22, Q32. This is third degree approximations, Q33. So here Q21 is the best first degree approximation or linear approximation. The best linear approximation is considered as Q2, 1. So its value is 17.87833, and Q32 is the second degree, best second degree approximation. So 17.8771155 is the best second degree approximation, and Q33 is the best third degree approximation. So this is the method, Neville's algorithm. So if the data points are given, x and y values are given, then we can approximate the values by using the formula given in step 2. So these are called first degree approximations. We are filling the other columns of the table. So this is first degree approximations, second degree approximations, and third degree approximations. So this is the method called Neville's method. So I think you can do problems on Neville's method. Only thing is the values of x and y will be changed. In place, instead of 8.1, 8.3, 8.6, 8.7, some other values will be given, 5, 5.2, 5.5, 5.6, and these values will be different, 19.48, 20.56, etc. So we have to determine this is x0, x1, x2, x3, and these values are q00, q10, q20, q30. Now we have to determine first degree approximations. So by using the formula, Neville's formula, what is the formula? Qi comma j x is equal to, so in second step, we have seen the formula. This is the second step. We have to remember this formula. Qi comma j is equal to x minus xi minus j, qi comma j minus 1 minus x minus xi, qi minus 1 j minus 1 by xi minus j. This is the formula we have to remember, and substitute the values of I is equal to 1, 1, 2, 1, 3, 1, 2, 2, 3, 2, 3, 3. We will get the polynomials. So q11 comma q21, q31, these are called first degree approximations. Q22, Q32 are called second degree approximations. So Q33 is called the third degree approximations. So after finding the first, second, third degree approximations, we can substitute the value of x at which we have to determine the functional value. So by using Neville's method, we can determine the value of the function, or we can interpolate the polynomial. So this is very, very important for the examination point of view also. So hope that you understood this method, and you can calculate the values and solve the problems by using this Neville's algorithm. Okay, thank you.